Yes, good morning, everybody, and thank you to joining to this presentation. So first of all, I would like to thank you to Vitrum to invite us to here, and especially Umberto. You did a nice work. Thank you very much to you. This presentation is a little different. It has a lot of the pictures from the different conferences and the papers to try to show to you what is it the trends now in the glass industry. And of course this disclaimer is important, and important things is only that to understand that information is only commodity that's grow when it's shared. Few words about this GPD anyway. When we did it, that one over 30 years now, and you can see that it's growing very fast to the one of the world biggest glass conference. But let's go to the real trends. Today's trends. What is it important is a data these days. Data is our future, and this one was excellent presentation also from Nokia, who gave it this presentation. But to see a little bit what happens in the 80s to the 2000, how the communication has been changed so fast. The same things, an evolution in the mobile telephones also, you know what happens over there. And when we go really from the telefax or telex to the digital world, that's give it to us a lot of the new opportunities. But Nokia was one of the speakers in a GPD in a previous time, and they gave it a nice presentation also in 5G and how it will be change our future. It's really give it to us now a lot of the opportunities, how fast is it, and what we can do with the different things in the factories and the communication side. And especially this digital factory side, it's coming, of course, important things, because it can be this partner cloud to connect it everything from the factory up to the production and then to the building side also. Digitalization also make it a total differences and a big step to the next years. Also, it has done it already. But it's really make it that same things than electrification, automatization did it earlier to the level of the new productivity. Then, of course, the circular economy is one important thing which coming also more and more important in these days. Energy efficiency, climate policy, energy performance in building, energy efficiency and renewable energy, those one are the things which driving our future. And then if you take a look a little bit how and where the glass is made, you know all that China is really leading this game. It has growing very fast, those float lines in China and production over there. At the same time, the prices has go down until now. Now it's, of course, we have a shortage on the glass again, and the prices has go up. But basically, in those 30, 40 years, the glass price has been very stable to compare to the other consumer prices. And this give it a little bit indication how the glass industry will be changed in the years. This is now from 2019. From CISESAM evaluation by how many million tons and what is it in dollars also, how it changed our future. And where we use it, the glass, construction side is anyway the biggest part, automotive 11%, and other application is about 7%. That's where all of those classes go. But the fastest growing area is really this multifunctional and smart coatings. They grow about 18 to 20% per year in different sectors over there, but we don't have a time to go to the more details on those one. And then also, this is now the US market. Decorative glass has been coming very popular over there also. And then massive timber and the glass and this low carbon mid-rise buildings is also popular in US, but mainly, of course, here in Europe, even more. Automotive side has been also to see a lot of the big changes on the screens and communication to compare to what it was in the 80s really. Now we have all of those head-up displays in the automotives and also those like the tractors and that sort of things. Same as the things is in the buses. Design trends, we have the transparency has been always important. This is in the left side is a picture from Paris already 1925, and then the 80s when we start to use it, those after the energy crisis, those small windows. But we are back really to the total transparency. These are the typical example. Left side is early days when they did it, when the glass was not yet as big as they are nowadays, and the right side you can see it really what sizes we can go and how much it's make it also difference in a transparency side. Now I have it in here a couple of pictures. What is it really the transparency means, what it can make it, and this is one nice thing is that what the size makes the difference to the view. And then the new things is also these transparent corners, which has been popular these days, and that will also to give it the new option and new opportunities to glass industry. Sliding doors has coming bigger and bigger and heavier, and they looks really nice to compare what we have it in 80s. Observation desk, many building has those one now, giving the opportunities to people to really to see it and to be in those sightseeing places. But the buildings also, the facade coming more complex, more complicated, like this one in Hamburg. This building was an excellent case study also the previous conferences. And the building shapes really are the different, what it was early days. And these new shapes coming really by the cold bending and then warm bending in a lamination side, or hot bending by gravity, or tempering and bending. There are the four major technologies to make it those buildings, and it's really shaping, let's say, this building like this top picture from Louis Vuitton in Paris, which was one of the nicest buildings to do it in this past years. But here are the couple of other examples, what it really means, how nicely the glass is really connecting the nature to us and be able to make it the different type of the facade and different shapes of the building. Is it the hot bended or cold bended glasses? Nothing matter, but we can use it still. Special glasses, we have it also some good, two good examples. This diamond factory who like to make it this kind of the special facade. Huge building or huge pieces what they use it in that facade. But also this chemically tempered glass, slump glass, what Nike use it in New York and then later in Shanghai also. Other good example is also those glass igloos, what has been done it in the northern part of the Finland to heat it up the inside and outside surface so that you have a fully transparent opportunity. Then if we go a few words about the structural glass design, Tim McLaren has been the guy who has been make a lot of the things in the past years, or beginning of 80s and 70s already, this one. And it has been used a different way to make it, let's say, the nice, real, transparent things in these days. And like this single model, what was Maffei's engineering to do with the new program to the whole process from the design until installations. Give option to know it which place the glass need to be in a building. Balustrade glass business has growing also very fast, and there are the new design options in many different things, same as this kind of the stairs and the steps. Different prototype has been testing also the many different way, and the universities do it a lot of the work in that one also to testing those glass beams, which is important to the transparency. Energy performance, like I say that one earlier also, it is energy and climate policy, energy performance in a building, energy efficiency and renewable energy. Those one are important when we try to get it zero energy building, which is actually quite close already to be able to reduce at least 50% of the energy consumption in the buildings in Europe. In Europe, still the U value is pretty low or high to compare what it's supposed to be. In Scandinavian countries, it's below 1, but average in Europe is 3.4. So it's really something what it was in the 60s already. Global carbon emission, you can get the idea a little bit where it happens and where and what we need to do with that one is also important things, but we don't have a time to go closer to that one. But the one what helps in that one is a PIPV, and a PIPV we can put it in a different place in the buildings. There are a lot of the opportunities to do it with that one. And now we start to get it also those transparent PIPVs, which give to us even more option, even that they are not very effective yet, but most probably in the future they can improve that one quite a lot. And building integrated photovoltaics is also, when we do it, those one architect wanted, let's say, the different style so that it's fitted to the building and the building facades. PV module production, annual production is almost 160 gigawatts already in this year, and totally we are close to the 800 gigawatts, which means quite a lot in these days. Like you know it also, like in Germany, the electricity price in a sunny, windy days go to the negative, so that's a different thing. But electrical price has been pretty high anyway here in Europe to compare to the Scandinavian countries. Few words about the facades and facade technology. It has been coming also the new tight bending glasses to use it in a facade, which is give it the option to give it a different outlook to the glass or to the building. There are the several technologies to use it that one and make it a different type of the buildings. And when we have a building, we have it usually the different type of the facade systems over there and different height, like we have it always. For example, these cable wall facades, and at the same time we have the other systems in the buildings. Façade performance, those close gravity facade has coming also, or double facade has coming popular in a different way to do it, that one, saving the energy and also to give it the ventilation to the building side. The designers always like to get it the best performance in a building, and there are the several companies who has do it a lot of the things, and like you see it always in here, you can see that whose presentation I have took it those slides. High performance facade, we can get it the very high these RW U values and G values nowadays, so that is not the problem anymore. It's just that how we want to use it, that one, in the future cases. And then we can use it a different facade system in a south or north side, and keep it that way, the, let's say, the different light transmission also. As you can see it in here also, we need to put it the different level, the light transmission in a high-rise building in a higher level and lower level to be able to get it that one. And this sort of the innovation we need to keep going in the future. Virtual prototyping is coming also popular, and get it this one, that how the facade will look really when we are doing let's say the final and actual picture from the building, so it's not too far away anymore in those one. Digitalization also to give it the possibilities to give it to us that what the facade looks like. Is it you can see it over there, the light transmission on the right side. Is it 60%, 50%? How it's changing the color and appearance of the facade. Again, this glass igloos in Finland, that's an interesting detail things to have it, those heating elements on a low E coating, where we have it, put it the 220 volts to heat it, that one. Inside just a 2 degrees or 1 degree higher, so you don't get it the cold feeling or cold war effect. And same time, if you have a heating in outside, you can smelting the snow load and everything out. And then if we think about it to use it, that one, normally we need to use it the ventilation or something heating system close to the facade, so it's coming very expensive to that one. But if you use it heatable glass, that is a new way to also to make it that one more cost effective. Then IGU Development, that one everybody knows what it was in early days and how it has been changing those machineries to coming those extra large IGU unit sizes. When we go to the up to 18 meters, they are really amazing things. And give it the idea also how quickly low-E IGU has really to growing up. Okay, the triple glazing over there looks to be very low, but I believe that in Scandinavia the triple glazing is more or less already the must to compare to the double glazing. But U factor matters also in a hot climate, and that is also then the different type of the glasses, how we do it, that one, and where we located those coatings. But we can go easily to the 0.7 U value in the windows nowadays, the total windows. But the frames, and if we are the hot climate, that is important also, those aluminium things, how we do it, those one, and what kind of the thermal breakage we have it over there. But basically, this one, all of these windows or whatever, is it insulating glass unit, can be do with the different type. Some newcomers are also this crystal clear silicone, which give it again total new idea and opportunities to do it, really transparent facades, and I believe that you have seen it, some of those ones. The problem also in insulating glass unit is that if you make it that one and you use it in a different level, you might be getting the quality problem, and that one of course is connected to the pressure changes, altitude changes, or even the temperature changes. It's make it the same things. It's a really pumping effect on those insulating glass unit is important, but the gravity equation is also the one where we can make it something more, and has been done it also in the past years. This sort of the new system where you have a hole inside in the gravity to be able to stabilize the glass. And the thermal shock is of course the one where we need to be understanding also the high-rise buildings and also the low-rise buildings. Quality control, and especially to measuring the argon inside in the gravity is important, and this kind of the online control system is important in the future, because you can't really to see that if there is argon or not. But we don't need it argon in this one. Vacuum glazing, we have been talking about that one more than 20 years now, and now it starts to coming at least in some cases already. At the same time, the smart glasses are also to take off. There are the switchable glass, thermochromic, photochromic. Those are the main three areas now. And a lot of the makers also, and a different object that where to use it in the right glass, in the right place. Of course, they are still expensive one, but they also give it a good option to reduce carbon things and also be the more cost effective in the future when the new technologies enter to the market, what looks like to coming in the coming years anyway. The old fashioned still works anyway if we don't have it. Then we have it those nice glasses in early days, and digital printing has been coming also important, and that one give it to us a lot of the inside architecture, but also the outside, and the lighting the glass in the right way, give it to us total different way. Printed glass outside has been coming also pretty interesting. This is supposed to be the video, but oh, it started again. Transparent display is one which already in the market, but coming more and more. This one which give it to us the total different area and ideas to the glass. Utilize the buildings, office buildings, or if we have it, let's say the different type of the transparent displays. I have put it in a couple of examples in here, how and what we can really to do with that one. It's amazing how they have been able to develop that one so fast also. This 3D facade is really the latest things. What I like it, that one, that it's really looking crazy things what you can see it, and it looks like the 3D TV in a large scales on the street, and looks really live. might be scaring to somebody in this one also. But technology side, what is it really? In a bird safety class is something which has been coming mandatory to some of the areas like New York, and most probably it's coming more and more important in Europe also. Cold bending is something where we really bended the glass against to the frame, and that is important. We have done it that one now over the decade in different buildings, and so far I haven't heard about any problem, and give option to the different type of the building to do it that one, and how much you can bend it that one. You better to take a contact to those people who has make it those studies. But you sometimes you really bending the glass inside the factory before you use the insulating glass unit, and that is really the manual work, and then they carrying over there, go up to the building site and then install it back to the same position as it is now to get it less stress to those joints. Thin glass is also the one important part in our life and in the coming years, where we can use it, how we use it, that one really, that 0.5, 0.7 millimeters glass. We haven't used it, those one very much now. Only the mobile telephone industry, tablets and those one, they use it, that one. It's a total different type of the process, like a float process. And you can roll it, those glasses, to be able to use it them nicely. But these are some examples what the universities has been studying that one to do with the different facade and different ventilation system also, or even to make it the digital printed glasses. Then when we go to the polycarbonated interlayers and the thin glass, we can make it a very light glazing also, and that's give it to us the new area also in to the glass industry. Then if we go a couple of words about the processing side itself. Processing, of course, was a tough job in the beginning, and we was in a different shapes, but nowadays when we go to the up to 18 meters long glass, it's give it a little bit different things, like what was a tempering, for example, in the 70s, to compare what is it now in the 2020. IoT is something where we can also to see a lot of the development in the future, how we connected this one to the ERP system, glass identification, go through the whole process until transportation, and finally to install it, the glass, to the right place in the right time. VDMA has done it a lot of this one. This is their latest presentation on GPD, where they like to take it advantages in this system to get it higher speed, higher efficiency, and higher quality. Again, this sort of the private or public network where all the machineries are connected until delivery and installation to the buildings. Coating is one which has been developed a lot in the past 30 years basically. It's given us now a lot of the option to get it that one to going and give it the way how we can control and reduce also the CO2 emission. And it's give it also a little bit different colors and that sort of things to the building when we use it the different coatings. Pre-processing, we still use it mainly the wheel cutting system, and universities has done it also, a lot of the studies on those one, what and how to do with those one. But the laser is also something which coming now. It's a cutting, shaping, grinding, printing functionality, marking the glass. Get it also these functionalities like telecommunication signals through the glass. And we are able to do with the marking now even to the edges, which give it a very good way to controlling our things. Few words about let's say the tempering. You know it that there are the two different major things, thermal and chemically tempered. So we don't go details on those one. But this glass tempering furnaces and the suppliers, there is plenty of those one nowadays. And you can find the different ideas and different technologies to do with that one. But the most important thing is to heat it up the glass to the right temperature, right time, so that we can get it the best quality out by radiation, convection, and conductive heat transfer system. But it also depends our production. Is it shower room, windows, or facade? We have different priorities in those production side. And that is also means that what kind of tempering furnace you might be like to selecting to your production. Laminating has been total different level. What is it in the past 30 years? Vacuum rings, we still use it anyway in some processes. Nip rollers is also used in these days still. It has been a long time over there, but it's still under the developments. Vacuum pack, basically in the EVA system is now very popular. But also it can be, let's say, to do it with normal PVP lamination with the heating by convection system when you don't see the differences. Is it the painted glass or is it clear glass or low-E glass? That can be compensated by that one. Or you can also to laminate the different metal pieces inside in a glass. Bending has been developed a lot of also from 80s to the 2000. The sizes are totally different. Nowadays you can make a complex bending and tempering, but also the U-shape is still the things what they use it. Anneal bending has been over there already 100 years, but those tempering bending and basically those complex bending has been coming now more popular. But the sizes has coming a huge one. If you think about it, let's say in a 20 years time, we are now up to 18 meters, and I believe that is it 21 meter now, the largest one, what to do with. So that's interesting things that how bigger we can go. My opinion is that it doesn't go anymore much bigger one or longer one what that has been. Those 20 meters are very difficult to handling, very expensive things, but also looks fantastic when you think about it, the total transparency. Warm bending inside an autoclave has been also the one interesting area to make it that one, and has been used it already a couple of years. I don't know why it's so unsafe, but let's see the quality-wise. Quality and quality control is something what we need to really to take it under the thing. So how we measure it, the glass in a tempering process, infrared cameras are important. Then color and thickness indication, and then this sort of the non-contact technologies which give it to us a lot of the information about these classes and quality. Anisotropy is a total different things, and it has been coming in the past 4 or 5 years more important, and there are now the different way to controlling this one and this white haze, or is it then this just to see those blue spots over there. Anisotropy is interesting because it depends also the angle where you're looking for that one, how much you have polarized light. Is it close to the sea, or you have a snow or the other building? It can be showing those anisotropy things total different way. And anisotropy is, let's say, simple way to explain it is a density difference in a glass, and then the light speed go through the glass is different. Those camera pictures and that sort of things can give it, let's say, the new ideas and the new things. What is it? Luis Morat from Angora gave it a very good presentation also in this one. Compare also those different makers who are on the market in these days. The white haze is the same things what you can also controlling at the same time. It can be removed also, but it's a manual work. Optical quality is a things where we have a lot of to do with. Still, even that we are pretty good shapes on those one. And fabrication, distribution on those rollerways, Quensmark, warping, all of those one are needed to be taken in account, that we don't destroy our glass market, because glass has a lot of the good potential to do with that one. But there is also that how much money we put in the quality control, and where are the optimal place to do with that one. New things are also this sort of the current counting system, automatic system by mobile telephone, which is giving immediate results to you. Nickel sulfide was one where we have it, let's say, discussion the long time. What is it? I believe that you know it, and how is it the tensile, or is it the compressed area, depending the size, which can be break it, that one. And there has been a lot of these different studies in the past years, and those one you can find it anyway on those proceedings books. Color side and a color combination, let's say, is also interesting, because the color depending coating, and then the coating color depending the angle where we get it the light. That is also the things what we need to keep it in our mind, and also how much polarization light we get it, left light or higher level, wherever it's coming. We need really to heal this our industry, so that we can have it more innovation in the future. And that is a couple of things what I put it in here together, that in my ideas on those one, that the most of the new innovation coming outside of the glass industry in the future. That's for sure, if we want to get it, let's say, the younger generation in electronics inside in the glass. And sharing the knowledge, different alliances between the industries are needed, and that is one of the most important things. Developing the cooperation between all stakeholders, that is the same things than sharing the knowledge anyway, but also that we need to be ready to that one. And also involving the startup companies to accelerate the development of the class and get it the new ideas where we have it already the good examples from smart class side. But the most important, the class has really potential to grow into the most versatile building material. But we needed that sort of the professional training, consulting network, and international cooperation before we can get it the things to move it and to be in the same boat. And last but not least, we have started this Old Fox Club in Finland, where with idea in that, but it's a leading knowledge sharing networks where we collecting the information and we give it that one to the educational purposes to the different universities, industry, designers, and to the, especially to the young professional and startup companies. In my opinion, that the Old Fox understand the traps. We have make it the same mistakes so many times, so we hope that we don't continue to make it this one. That was part of my side in this one, and if you have any questions, I'm happy to answer to that one. It was a pretty quick to go over those almost 200 slides together, but give it perhaps and hopefully something to think about it, what we can do it. And if you are not yet in my LinkedIn group, please join to that one. Thank you.